Okay, Stacy, this is page 306. This is 7-63. You didn't say whether you needed letter A, B, C, or D, so I'm going to start with A. It says, for each equation below, solve for x and check your answer. So I think if this were my equation, I would probably want to use the distributive property because I have a number right next to parentheses, so I can distribute, multiply 10 onto each of the numbers that are inside the parentheses. So I know that when I multiply by 10, it just scoots the decimal place over one to the right. So this 10 times this 0.02 turns out to be just 0.2. It moves one place to the right, 0.2x, if that's okay. And then this one will move one place to the right. So this will be 0.1. And that's equal to 1. Now I can continue working in decimals right now if I want to, or I can get rid of the decimals if you don't like decimals. I don't really like decimals, so I've decided I would like to multiply again. I'd like to multiply everything by 10, because if I multiply by 10, it's going to scoot it over one more place to the right. Okay, so I can show that just by, I guess I can show that by going like this. Now I'm doing it to the whole, to every single term. Okay, so 10 times this first term is just going to scoot the decimal one place to the right. Now I've got 2x. 10 times the next term, well, that's going to give me, scoot one place to the right, that's going to give me 1. And 10 times 1 is 10. Now I can solve it using the algebra that I know. I can isolate the x by adding 1. And that gives me 2x equals, oh, not very nice, 10 plus 1 is 11. So then, now I have x equals 11 halves. Now to check that, because I do want to check it, because I got a fraction, and that is not making me super happy. 11 over 2 is actually 11 divided by 2 is 5.5. Oh, I guess I could have done that without the calculator. So 11 over 2, that's 5.5. I'll just write it right there, 5.5. So I can plug 5.5 into the original equation and see if it makes it true. So now I've got 10 times 0.02 times 5.5, because that's what x was, minus 0.01. I don't like those leading zeros. They just waste a lot of ink and room on my paper. Okay, so if I just do this calculation, and if the left-hand side ends up being 1, then I'll know I did it right. If not, I guess I'll rework it. 5.5 times 0.02 turns out to be 0.11 minus 0.01. So 0.11 minus 0.01 is equal to 0.1, and 10 times 0.1, is that equal to 1? That's my question. If it is, I'm going to be pretty happy because I'm done. It is. So that's 1 equals 1. So this is that I checked it. That all that work over there is my check, because it said check it. It said solve it and check it. Okay, so this video can only be less than 10 minutes. So I'll do A and I'll do B, and then when I get close to running out, then you know, if you still don't understand how to do the rest of them, you can email me back and maybe I can put some more on here. And the next one is 1/3 x minus 6 equals 8. And again, I'm going to use that same technique. I don't feel like dealing with the fractions for this whole problem, so I'm going to do whatever I have to do to get rid of that fraction. So in my book that I teach out of, it's called Fraction Busters. I'm not sure what you guys call it in your class, but if I multiply this whole thing by 3, that is going to clear that fraction. Because what's 3 over 1 times a third? Or in other words, what's a third of 3? It's 3 times a third is actually 1. You can work it out on scratch paper. You can go like this. Oh, you can't see. If you work it out on scratch paper, see, it goes like that. So, by multiplying this first thing by 3, I got rid of the fraction, and then I'm just left with 1x. And that's nice. Now, 3 times negative 6 is negative 18, and 3 times 8 is 24. And to solve this, pretty easy, just add the 18 to both sides. Trying to isolate the x. That's what it means when it says solve. And then 8, that's 12, 2, 3, that's 42. I think x is 42, so now it said I have to go check it. So I remember that the original problem was 1/3 times x minus 6 equals 8. So I think that x is 42, so I'm going to check that. Now I think 3 goes into 42. Just think so. It turns out that 3 times 14 is 32, so I can cross cancel these out. 3 times 14 is 42. So now I have 14 minus 6, is that equal to 8? Well, yeah, because I know 14 minus 6 is equal to 8. So I checked it. Okay, maybe I have time to do another one. That was letter B. This is fun. Oh, you can't see all of it, huh? Fun. Okay, so here's letter C. We'll just keep going until I run out of minutes. X over 3 plus 1 is equal to x over 4 minus 1. So again, I'm trying to solve these, but since they have fractions in them, I'm using this technique that my book calls it fraction busters. So the thing I want to multiply by to get the 3 and the 4 to go away would actually be 12, because both 3 and 4 both go into 12. Like, in other words, if I were trying to get a common denominator, it would be 12, right? So that's the number I want to multiply everything by. So I'll do that in red. This is how I show it. There might be another way that your teacher wants you to show it. I'm going to multiply by 12. Okay, so when I multiply x over 3 by 12, that's kind of like saying I have 12 over 1 times x over 3. The 3 and the 12 will cancel out. 3 goes into itself once. 3 goes into 12 4 times. So I'm going to get 4x right here. Now 12 times 1 is pretty easy. 12 times 1 is 12. I have to do it to everything. That's why I'm drawing these little rainbow things. Now the 12 and the 4, there's also going to be a cancellation, because 4 goes into itself once and it goes into 12 3 times. So I'll have 3, that's going to turn into a 3x. And then 12 times negative 1 is negative 12. Now I have an equation that you probably know how to solve. I want to get the x's by themselves, or isolate the x. I like to subtract 3x on both sides. That's going to cancel out. I would like to also get rid of this 12. So as long as I do the same thing to both sides, right, put negative 12 on both sides, that goes away. 4 minus 3, that's just x. And that makes a negative 24. And I'm just about out of time. So what you would do to check that is to plug the 24 back in up here. If we can do it in our minds, let's do it in our minds. Negative 24 divided by 3, what's that? Negative 8? Yes, it's negative 8. Negative 8 plus 1, that's going to make negative 7 over here. Okay, negative 24 divided by 4 is 6. Negative 6 minus 1, that's negative 7, so it checked. Okay, let me know if you need more help. Bye-bye.